additivity property states that any output current or voltage of a linear resistive circuit with multiple inputs can be expressed as a linear combination of the several inputs. And what do we mean by that mathematically is that I'm given an output Y. I'm going to have inputs X1, X2, and X3. It's going to be a linear combination, which means we're going to add them and we're going to multiply it by scale factors or constants. So because of linearity, we can take each individual input and see what the individual output is. That is, the output due to X1 is just Y1, the output due to X2 is just Y2, and the output due to X3 is just Y3. So the output is just the outputs due to each of the individual inputs. Now we can show this in block diagram form. Where I have an input X1 gets multiplied by K1. The output of this block is K1X1, and that's just Y1. And we're going to feed it through a summer. Later on we'll show how the multiplier and this adder here can be modeled with operational amplifiers. This is K2, K3. Input to K2 is X2, and input to K3 is X3. And our output Y is due to the outputs of each of these multipliers, Y2 and Y3, where Y2 is X2 times K2, and Y3 is just X3 times K3. So this is what we mean by the additivity property associated with a linear resistive circuit. For the sake of completeness, let me put Y is output due to Y1 plus Y2 plus Y3. Now let's look at a circuit which we're given here. We have two sources of input, one due to a current source, one due to a voltage source, and we have a resistor R1 at node A. Here's our ground point, and we have another resistor R2, and we want to know what our output is, VO and minus, right there, as the polarity is shown here. Now what we could do here is find the output due to each of these inputs. So let's start off with VS. Well, VS is just going to go through where we remove one of the sources, say IS, and we want to find the output 1 due to the voltage source and the output 2 due to the current source. Or I can relabel this as VO1 plus VO2. Okay, VO1 is due to the voltage source, VO2 is due to the current source. So therefore, with VS, and when we remove IS, that means it has infinite resistance, so we can remove it. So, plus and minus VS, we can redraw this, and we see that R1 is in series with R2. So this is VO1 due to this voltage source, and that's just simply the voltage divider, R2 over R1 plus R2 times VS. Now let's do one due to the IS alone. Well, we have to redraw that circuit. Ideal voltage source, if we want to remove it, has to be a short, since it has zero resistance. So when we redraw the circuit for IS, we see that when we short the VS, that R1 and R2 in parallel. So if I short this guy, we see that this end of R1 is connected to the opposite end of R2 here, and the opposite of end of R2 is connected to the other end of R1. So they're connected in parallel. So I'll just redraw that circuit. Let me draw it in black. So here we have R1, and here we have R2 with VS remove. And so we have I2 there, and that's basically VO2. But VO2 is just using the current divider as the opposite resistor, which is R1, over R1 plus R2. So that's our analysis so far. And then because this circuit is linear, we add the outputs VO1 and VO2. We're not finished yet because this part is just I2. Okay, so that's the current divider part, so we need to multiply this by R2 to get the voltage VO2 due to this current source IS. So now that we completed that, we can add the outputs VO1 and VO2 as follows. So VO1 is equal to R2 over R1 plus R2 VS, and VO2 is equal to R1 for R2 R1 plus R2 due to IS. Adding those outputs, we have R2 over R1 plus R2 VS, this is due to VO1, plus R1 R2 over R1 plus R2 IS, and that's due to for VO2. Now we can rewrite this where we just have a constant right here. So we can take this constant and define that as K1, and this constant and define that as K2. Therefore, that's equal. Therefore, VO is K1 times VS plus K2 times IS. So what this result shows is that the output is a linear combination of the two inputs. Our inputs is a voltage source VS right here and a current source IS multiplied as a linear combination of K1 VS plus K2 IS, where K1 is defined as a ratio of these two resistors and K2 is a ratio of the product of these resistors over the sum of the two resistors. Okay, so the units of K1 is dimensionless and the units of K2 is in ohms. So this illustrates the concept of additivity associated with this circuit.